Can you guys hear me okay? Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Okay, Osvaldo. Good to see you. I don't think I've seen you in a while, but welcome back anyway. FOQT, that's right. Your location and the test you're taking. And you've done that. Thank you for checking in. Please hit the like button. Let's see. So yeah, we're all settled in. New office. New board. I actually have double boards because sometimes if I'm in the mood for, if I need more room to write on, we have it here. So let's get into it. Tyler, I don't know if I mentioned, but Tyler, he passed the ASTBE, which is the Navy's Aviation Selection Test Battery. Part of that is the OAR. Thank you. I like it. Okay, there's more people in the room. Holla at me. Who's in here? Let's get some questions in. And as usual, you guys know, all right, Carol in the building. Maria's in the building. All right. Okay, anybody new in the room, new to the room, because everybody hasn't checked in. Okay, Asan, Philadelphia. What test are you preparing for? Hey, Avery. Avery's in the room. Good to see you. Good to see everybody here. All right, FOQT. Asan, okay. Very good. You've come to the right place. I don't remember ever seeing you. Is this your first time here, Asan? And please forgive me if I'm pronouncing your name wrong. Okay, second time. All right. Okay, so you've been here before. I don't know why that is I don't want to call it unusual, but it's very different, the name. And I watch for names like that because I have a unusual name. Everybody's not walking around with the name Kino. So typically, anybody new to the room, this is how this works. You'll take a photo with your smartphone of the question that you may be having problems with. If I can type, that would be a plus, wouldn't it? Okay, so on the message board, that is the email that you guys will send your questions to, and I will answer them. Like I said, anybody new to the room, and guys, please hit the like button for me, or dislike. Doesn't matter either way. But anybody new to the room, if you're taking the ASVAB, the AFOQT, the SIFT, ASVAB, AFOQT, SIFT, the OAR, which is just the general officer portion for the United States Navy, Marine Corps, and Coast Guard, or the full aviation selection test battery, which also includes the OAR. This is the place to be. I'd like to thank you guys all for coming out and checking out the channel. And as soon as I get some questions here, we'll start executing them. All right. Okay, this is a mixture problem, and we've done this a lot of times before, so I'll do it again. Mixture problem is something that you will probably see on all military aptitude tests. Maybe not the ASVAB so much, but definitely the other ones. So I'll type the question in so everybody can see it on the board. Maybe I want to. I'm sorry, guys. What's going on over here? Pull this window down and over. And. Okay. All right. Almost there, guys. Give me a minute. Had a little typo in there. So the question is, how much pure acid must be added to 10 ounces of a 55% acid solution in order to produce a 75% acid solution? And the answers are 5 ounces, 6 ounces, 7 ounces, or 8 ounces. So I always do my little container thing. So container 1. Let's go a little bit darker. Container 1 plus container 2 is going to equal our final solution. This is pretty much how I, train people to do these problems. All right, so we have quantity over percent, but we write it out in decimal form. All right, so we have 10 ounces and a 55 or 0.55, which represents 55% of a solution. And pure acid, the pure acid is the unknown. We don't know how much we're going to add, but 1.0 is the pure acid because it's 100% acid. And basically what we want to do is mix these two containers, and we want to produce a 0.75 or 75% solution. All right. So our answers are 5, 6, 7, and 8 ounces. So this is our construct. All right. So what we're going to do is we're going to multiply these two downward. So what we'll have is 10 times 0.55 plus, note the plus sign, x times 1, and that will equal 0.75 times the sum of 10 plus x. That's how you set it up. And then basically you just solve for x. All right, so I'll go to the side here. Let me just back up. All right. So basically what we're going to do is we're going to multiply 10 plus 0.55. If we multiply 10 by a number with a decimal, it's just basically the decimal point is going to move over. So this first section is going to be 5.5 plus 1x. And 0.75 must be distributed. Again, 0.75 times 10, the decimal point is just going to move over 1 point. And plus 0.75 That is a 5, guys. And I'm sorry, because that 5 looks retarded. Okay. So just type in clear, guys, if we're clear up to this point. Working that out. Let me just get 3 clears and I will proceed. And I know that there's a time delay. Got 1, 2, 3. Okay, so we got at least 3 clears. Okay, so at this point, what we're going to do is combine like terms, and we look for the side of the equal sign where it's greater, where x is greater on this side. So 0.75 is going to jump, become negative, and then we will have 0.25x, right? And then 5.5 is going to go to the other side, and then we're going to have, what are we going to have, 2? Yeah. So x is, if we divide that with both sides, just think of a quarter. How many quarters equals $2? 8. So we will have to add 8 ounces and wind up with a 18-ounce solution. And that will give us our 75% concentration that we're looking for. That question was given to us by Caroline. Thank you for that question. All right, so to recap, I like to, in my head, when I teach it like this, but in my head, I do it like this. But this is container 1, this is container 2. Quantity times the percent, but the percent is written out in decimal form. All right, so, and a little rule about decimal conversion, just so you know, 0.55 is 55%. We go from decimal to percent by moving the decimal point over 2 points. So 0.55, moving the decimal over 2 points is 55%. 1.0, moving the decimal over 2 points is 100%. And 0.75, moving the decimal over 2 is 75%. So there's a little decimal conversion to show you how you do it and why we do it like that and everything. So that's basically it. And let me get 3 clears if you guys understood what I did. Okay. Now, the next one that we're going to do is and it's on, you will never see a question like that on FOQT. You just won't. I don't know what book you got that out of, but some books, they put these crazy questions in the book to make their book look like, oh, this is really preparing me. But in my 10 years, I've never had someone come back, a client come back in a debrief and say they saw something like that. The mixture problem you just saw is basically pretty much as the strongest type of question that you will get on the AFOQT. I've never seen a question like that in a debrief. So you want to be careful. You want to be careful with that. And I want to just go around a little merry-go-round here. So yeah, my two latest scores. We get Tyler. He came in with I want to say it was over 50, and Dennis was over 50 as well. He actually scored a 59. I don't know why. I can't remember. Uh, I can't remember. And I'm sorry. I'm looking for a particular. Uh, boom, 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 boom. All right. All right, guys. Hold on. Coming. All right. Because this one question, I'm pretty sure I've seen this before. Uh, okay. I think Maria sent this question. I can't remember. But let me pull this up. It's a pretty strong question, but it's all in how you set it up. And let me see. Come on, buddy. All right, it came across. Very good. Okay, so here's the question. It might be, yeah, it is too big. All right. Okay, there's more. Just give me a second to get this all on the message board. There we go. All right. Here we go. All right, so in a 3-hour examination, you're going to get 320 questions. There are 40 math problems out of the 320 questions. If twice as much time should be allowed for each math problem as for the other questions, how many minutes should be spent on the math problems? And let me see if I can't. No, it's not letting me. So our answers are 40, 45, 50, and 55 minutes. All right, so anybody's been training with me, we know we solve word problems line by line, line by line. When you do it like this, when you do it line by line and you diagram, then what happens is you get all the information out there on black and white, and you can kind of see everything, and then it will help you execute the problem more efficiently. Do not try to do this stuff in your head. Put it all on paper. Put it all on paper. Okay, so the way that we set this up is, all right. The question says we have 3 hours. So we got 3 hours and we have 320 questions total. All right, so I'm writing out 3 hours or 180 minutes. I'll probably break it down 180 minutes because they want to know how many minutes should be allotted for the, if twice as much time is allotted for the math problems. So I'm going to write out the full number of minutes. And let's see what else we got here. In this particular question, because I've seen variations of this question. I've seen some say 50 math problems, 40 math problems, but in this case, we have 50 math problems. I'm sorry, 40 math problems. I've seen 50 somewhere. All right, so we have 40 math problems. So that means out of 220, there's 280 English. I'll just put English or, reading comprehension. So the two together equate to 320 questions. We have 180 minutes to accomplish this. Twice as much time is going to be spent on math problems. So actually, it's almost kind of like a problem, but we're going to have X represent time, and we're going to have 40 represent the math problems. And then what we're going to do is we're going to have X over 2, and we're going to multiply that times 280. All right, so X represents time, but we have 180 minutes that we're going to do this in. All right, so what we do is we distribute. All right, so this is going to be 40x because x times 40 is 40x plus, and think of this as a fraction. When we multiply fractions, just think of it as x over 2 and 280 over 1. All right, so we have 280x over 2. When we divide that by 2, it's going to become 140x equals 180. All right, type clear. I need 3 clears if you guys are with me so far up to this point. Okay, because I don't want to lose anybody. If anybody is lost, speak now or forever hold your peace. So we break this down into sections. I have 1, 2, okay, 3 clears. Okay, so now this is how you set it up. So X represents the number of minutes, and half as much time is going to be spent on the English questions. So that's why we set that up, and we have 180 minutes. We distribute the X and the X over 2, and this is what we come up with. All right. So all we have to do is basically just combine this, and 180x is equal to 180. So x, the number of time of math problems, is going to be 1 minute. All right, 1 minute. So the question is asking us how much time is going to be spent on mathematics problems. Well, x times 1, which is 40 minutes total, because we have 40 math questions. So 40 math questions, we're going to allow 40 minutes to deal with those math questions. All right. All righty. Just make sure. So Maria, you have 50. I think you meant to type in 40. But 50 would just be replaced here in that case. And if that's 50, then this would actually be 270. And you just do the same thing. The math is pretty much all the same, whether it's 50 or 40 math questions. All right, going to the email. And we have some more guys that are about to, well, this month, are planning to go ahead and take the test as well. I'm looking forward to those scores. But there's something I wanted to talk about. I can't remember. My computer's moving slow for some reason. I'm actually, I guess by next month, I'm actually building another one. Got that one. All right. Now, there's a variation. Now, Carolyn, she sent me a question, and we can answer these questions many ways. Okay, make sure all, and let's see. Answers are 1, 2, 3, and 4 days. So we'll do them both. All right. So, in our question, a naval detachment has enough rations to feed 16 people for 10 days. If 4 more people join the detachment, how many fewer days will the rations last? That is the question, folks. And so, line by line, we look at a line, diagram, we look at a line. All right, so initially, our situation is we have 15 people. No, I'm sorry, 16 people. So we got troops, 1, 6, 16 people. And the number of days we can feed these guys is 10 days. All right, that's the first sentence. If 4 more people join the detachment, how many fewer days will the rations last? 1 fewer day, 2 fewer days, 3 fewer days, or 4 fewer days. So what we're going to do is we're going to let X be the number, and it's basically like a proportion because we're going to have 16 times 10 equals 20 times X. It's that simple. All right. So we have 16 people. We got enough rations to feed them for 2 days, 10 days. And then we have 20 people. And then X amount of days we're going to be able to feed them. All right. So 16 times 10, we just add a 0. Anything multiplied by 10 is just adding a 0 to it. So 16 times 10 is 160. And then we have 20X. Now, what we're going to do is we're going to divide 20 on both sides. So 160, 20. All right. And that's actually going to be 8. Okay, so the 20 troops, if we add 4 more troops to this situation, so we don't have 16 anymore, we have 10. We have 20 instead of 16 troops. And basically what's going to happen is we'll be able to feed all the troops, the 20 troops, in 8 days. So the answer is 2 fewer days. So 20 troops will be able to be fed in 8 days, 2 fewer days. And that is the answer to the question. Give me my clears, guys. Not that I know of. I just know how to do it algebraically. You could just plug and play with it, but you still need to algebraically know the sentence. And it's pretty easy. You got number of days equals number of days. It's a proportion, basically, in a sense. All right. 16 times 10, 20 troops are added, or 4 more troops are added to the situation. And so X is an unknown number of days. So it is number of people times days equal number of people times unknown days, or new number of people times unknown amount of days. So it's just 2 fewer days. I mean, I don't know how else to explain that. I apologize, but I don't. And I don't know. Maybe I need to go harder because I only see 2 clears. I know there's a time delay, but I only see 2 clears. So only 2 people in the room actually understood the method. Is that what I'm getting? If anybody doesn't understand, just say, hey, could you explain it again? But I mean, actually, yeah, I got more. You got it, but all right. I saw you clear before. Is there another method? Is what I was focusing on, but I see it now. So, um, you know, if there's somebody out there that doesn't understand it, just stop me. I'll, recap for you guys. That is why we are here. Okay. Eliana, hey! Long time no see. I hope everything is good on your end. I hope everything is well on your end. Okay, next question. Okay, no problem. Where did you get the 8 days from? The 8 days is the unknown number of days. So, like I said, it's set up like this: number of troops times days equals new number of troops. I'll put new above that. Of troops times unknown amount of days, which is just represented by X. So it's still number of troops days, new number of troops days. And 16 times 10, number of troops, number of days equals new number of troops, number of days. Because that's what the question is asking. How many fewer days? Well, we come up with 8 days. 16 times 10 is 160. 20 times X is 20X. We divide both sides by 20. We come up with 8, our number of days that it will take if we add the troops, the new number of troops, to the naval detachment. Okay. So imagine this is something like a real world like example. If you have troops and rations and you have to feed them, and then all of a sudden you're assigned 4 more troops. They're like, okay. So you, as the leader, you got to look at your rations and make sure everybody's, they're getting their sustenance. They're getting their food, they're eating, so they can be good for whatever mission that you guys are performing. All right. I've seen this before. Oh, too much. Okay, I'm gonna have to put this in 2 parts. Sorry. All right, here we go. Okay, so this is 2 parts. All right, and I will actually put the answers. Whoop. Okay, two office workers have been assigned to address 750 envelopes. One addresses twice as many envelopes as the other. If it takes 5 hours for them to complete the job, what was the rate of the slower worker? So this is kind of like a distance, rate, and time problem. All right. So again, word problems, line by line. Word problems are probably the biggest issue that people have. All right. Taking the words and translating them properly in the math. So two office workers have been assigned to address 750 envelopes. So we have office worker 1, office worker 2. They're going to have a rate and a time. Rate times time is equal to distance. Distance equals rate times time, or work done. All right, so what the question is telling us is that one addresses envelopes twice as fast as the other. So worker 1 will assign X and worker 2 will assign 2X for the rate column. All right. So what else do we know? It takes 5 hours for them to complete the job. All right. So together, it's going to take 5 hours for them to complete the job. So basically, 2X plus 3X. No, 1X. I apologize. 1X, and this is 2X. All right. It's actually going to be 3X. So that is the combined rate, or like we do in just distance, rate, and time problems. We have a closure rate or expansion rate, but it's the sum of the two rates of the two vehicles, aircraft, or whatever. So 3X. And they're going to run for 5 hours. And that is going to equal 750 envelopes. So 3X times 5 is 15X. And if we divide, let's see here, 15, 750, 1, 2, 3, 4, 65. Okay. 575. The decimal's here, so we add a 0. So the slower worker does 50 envelopes, and the faster worker does 100 envelopes per hour. Their combined rate is 150 envelopes per hour. So 5 hours they'll complete 750 envelopes. What did I want to say? There was a point in my head I can't remember right now. Yeah. So the slower worker is what the question is asking for. What was the rate of the slower worker? 50 envelopes per hour. Right. So I'll recap. To recap, two office workers have been assigned to address 750 envelopes. One addresses twice as many as the other one. So this rate is X. This is the one they're doing it twice as fast, and they're going to do it for 5 hours. We combine X and 2X, which is, oh, sorry about that, I got a text, which is 3X times 5, and that equals 750. All right, so that is the recap. Any questions? Please type clear. Somebody said very clear. That's good. I'm glad it's very clear. Okay. Okay. You can't see it. Um, but we have a situation where I'll put it on the board. We have a situation where we have a circle. Damn, that's pretty good, guys. I always say, don't laugh at my artwork. Yeah, that's pretty much the center. O. And then we have an angle sweeping out this way, and an angle sweeping out this way. And then we have A, and we have B, and then we have a line going across like that. And then we have angle X here, and it's telling us that this arc length is 70 degrees. Okay. And the question is asking, what is the measure of angle X? And our options are 35, 45, 55 degrees. These are all degrees. And 70 degrees. All right, so 35, 45, 55, and 70. Okay, so as I look at that, if this arc length is 70 degrees, then that means this angle here is 70 degrees. It's a 70-degree angle. All right, someone type in on the line, how many degrees are in a triangle? If you know. If you don't know, I'll tell you. But anybody, just type in how many degrees are there in a triangle. 180 degrees. Very good, Caroline. So if there's 180 degrees total in this, and we've already used 70, then that means that there's 110 remaining. We divide by 2, 55 degrees. So this is a 55-degree angle, and this is a 55-degree angle. So angle X is what they're asking for. Angle X has to be 55 degrees, which is option C. All right. Let me have clears if you guys understand. Two more. One more. Very good. All right. Little quick memory aid. Sometimes people, they have problems when they are trying to remember formulas. And one of the formulas that people have concerning circles is the circumference and the area, C and A. What I do when I think about circumference, I think of 2 pi r when I think of circumference. And then when I think about area, what I say in my head is when it comes to area, we still have pi r, but the 2 jumps on top of the r. So circumference is 2 pi r, and area is pi r squared. Difference between area and circumference of a circle. The circumference, if we walked around this circle, that would be the circumference. It's kind of like a perimeter, but perimeters typically deal with like squares or rectangles. And the area is actually the filling. All right. So that is, and then you just kind of plug and play numbers. We know that pi equals 3.14. All right. So all you have to do is plug and play. If you have a radius, all you got to do is just plug it in. 2 times 3.14, which in my head are automatically think 6.28, because that's double 3.14. So I don't even really deal with this. I'll just say in my head 6.28. And then if they give me a radius, I'll multiply that radius by 6.28 and then I'm done. One thing that I wanted to cover, all right, if you're taking an OAR and if you're taking an OAR or the ASTB, a lot of people have been, I noticed this week, a couple clients that I've had are misconstruing Newton's 3 laws of motion. All right. Sir Isaac Newton, or basically for our testing purposes, there are 3 laws of motion that we deal with. Okay. 1, 2, and 3. All right. 1, 2, 3. The second one is easy because it's just expressed as a equation where force is N for newtons, mass is kilograms, and A are accelerations in meters per second. So law number 2, force equals mass times acceleration. The first one, an object at rest will tend to remain at rest. All right. So you have these dry erase markers in my hand. I'm just kind of sitting there. Okay. They're at rest. Okay, they're not moving. They're not moving up and down. They're supported by my hand. All right, so an object at rest will remain at rest. Now, let's say, I don't know, I went up to the, top of the building and I release this, okay? It's going to be in motion and it will continue to be in motion until an object, external objects, stops it. All right. Oh, I dropped it, but so it stops when my hand interferes with the fall. So an object at rest will remain at rest. An object in motion will remain in motion unless an outside force interferes with it. All right. It's Newton's first law of motion. Newton's second law, force equals mass times acceleration, which is right behind me. Newton's third law, for every force, there's an equal opposite force. Now, when we think about Newton's third law of motion, I do this in a way where I'll talk to the client and I'll be like, okay, you're sitting in the chair, right? And they'll say, yeah, I'm sitting in the chair. Well, gravitational pull is exerting itself at 9.8 meters per second squared, or 32 feet per second squared. Anything near the earth is going to have that gravitation. Right now, it's acting on my body right now. 9.8 meters per second squared. If I hold this dry erase marker here and then I let it go, it's going to start moving at 9.8 meters per second squared or 32 feet per second squared. Don't let that throw you off. There's gravity. That's all I'm saying. So, as you are sitting down in your chair right now, watching me on live stream, okay, let's examine some forces that are at work. Because Sir Isaac Newton's third law says for every force there's an equal opposite force. So let's look at force 1. Person is sitting on the chair. The chair is actually providing an upward force to support you as you sit in your chair. Let's look at another force. The chair and your body is exerting weight on the floor. And then the floor is supporting you. All right. So this is the easiest kind of demonstration that I can give you. All right. For every force, there's an equal opposite force. The same force that is pushing you down into the chair is being reacted 2 by the chair actually supporting you. All right. And the force of your body, or the weight of your body in the chair, the gravity produces this force to push you down towards the floor, and the floor actually supports you. So, 3 laws of motion. These are just like one of those things you must know. You have to have a operational idea of when you're thinking about physics for you OAR, ASTB, and SIFT guys. All right. So to recap, law 1, the object of rest will remain at rest, and the object in motion will remain in motion unless an external force interferes with it. Number 2, force equals mass times acceleration. And Newton's third law is for every force there's an equal opposite force, which I've just demonstrated. All right, so this is something that I want us all to be clear about. It's just kind of need to know stuff. And gravitational pull, 9.8 meters per second and 32 feet per second. And if you guys want to know more, I'll deal with my clients on a one-on-one basis as we go along. All right. All right. Okay, I'm not even gonna okay. I want to be nice. I'm going to be nice. I am going to be nice. I'm not like upset or mad or anything, but you guys, I keep telling you guys, if you guys been watching my live stream for right now, test makers are very, very lazy. And you want to be able to see the 3, 4, 5 triangle. Okay. Now, how many in the room know about the 3, 4, 5 triangle? Just type in yes. And if I get a couple, we'll move forward. But the 3, 4, 5 triangle. What I mean by that, this is concerning a right triangle. And if one side is 3 and the other side is 4, the hypotenuse is 5. Automatically, it's a no-brainer. You don't have to think about it. Thanks, Ileana. And thanks, Caroline. It's a no-brainer. And I always talk about this 3, 4, 5 triangle. I've been talking about this 3, 4, 5 triangle for months. I can make thousands of questions. Thank you. Thank you, Ileana. And it was good to see you, hon. So many questions can be made off of this 3, 4, 5 triangle. It is insane. During the assessment, I always do one. And it's not that it's a 3, 4, 5 triangle, but it's kind of real weird, and it's kind of like this, and you got 80 here, you got 60 here. Now this is a variation of 4, and this is a variation of 3. Why do I say that? Because 4 times 20 is 80, and 3 times 20 is 60. So this hypotenuse, if this is a right triangle, is automatically going to be 100, which is 5 times 20. All right. So you guys have to be able to see this parallel so you can nail these questions and move forward. Okay. Because time is of the essence. All right. I could say another thing I could say is boat 1, we leave a port. Boat 1 goes 90 miles west. And boat 2 goes 120 miles north. And the question will ask, after these guys do this guy does 90, this guy does 120. How far are they apart? 150, no brainer. All right. This is a variation of the 3 times 30. This is a variation of the 4 times 30. 4 times 30 is 120. 3 times 30 is 90, which is here. So the hypotenuse is going to be 150 miles automatically. All right. So when you can see the 3, 4, 5 triangle, that's beautiful. It saves so much time. because you can dedicate that to answering other questions. All right. So we don't want to waste time when 3, 4, 5 triangles pop up on exams, because it's like easy. I've just been, I don't know, it's something I figured out, I don't know, maybe 5, 6 years ago or something like that. And I tell everybody, oh, that's a 3, 4, 5. And they kind of look at me like, what are you talking about? It's like, it's a 3, 4, 5. That's how I just spit it out now. But no, that is, that. Alrighty. Okay. If you guys want to come to the Google Hangout and you're a client and you've done a lesson this week, or Maria, you're cool, don't worry. Please send me an email. All right, send me an email. Because if I sit around and I don't see email in 15 minutes, then I'm gonna go get some wings. You know what I mean? So make sure you send the email. Because, hey, 10:15 rolls around and I'm going to get some wings. I'm like, look, okay, I guess don't nobody need me. So, but typically the Google Hangout is just for my clients. And I give them extra time in the Google Hangout where they can ask questions. And in a video chat, everybody's in the room, and I just go by person, and I directly answer questions, and it's pretty cool. So there's really not much that's going to be accomplished, and I would like to start the live stream on time as best I can. Avery, I see your email. Caroline, I see your email as well. And Maria, you're good. All right. I'll send a link to your Skype. But here's a resource. I'm here every week I'm here. I try to be here every week. With my move and everything, some things came up. But as I settle, we'll be back on track. All right. These tests are nothing to play with. You have 2 to 3 opportunities to take these exams. All right. And they get harder the second and third time that you take these exams. For instance, our AST, thank you. The ASTB it's a reactive test. All right. It knows you took it before. So there's a second tier of questions you're going to get. I recommend anybody sees this video, your recruiter be like, hey, just take it. See how you do. Do not do that. I'm telling you, do not do that. It doesn't even have to be with me. Just get with a tutor that knows about these exams. I've just had the benefit of, just tutoring people for like a little bit more than 10 years on these exams and stuff like that. And, just get with somebody, because a lot of people, they try it on their own, and, it's bad when, you've taken this, and I'm not pointing fingers at anybody, but the third time, it's going to be the hardest challenge for, like, say, the OAR or the FOQT. You can't play with this. Don't play with this. Don't let the recruiter, just take it, see how you do. Because you're not going to be prepared. You're going to take it. You may not get the score that you want. And then you got the second and the third tier. So it doesn't necessarily have to be me. Get with anybody. That, you can Google people, I guess, and stuff. And, I know quite a few ASVAB guys. I don't know. I'm the only one I know. I know somebody I do ASVAB. Do you do FOQT? No. Do you do A? No. Just do ASVAB. I do them all, and I've debriefed with my guys, and I've had the benefit of actually having knowledge about a lot of the test questions that commonly show up on these exams. So my thing is, don't take it lightly. 9:59. So again, my website is www.stemwithkeno.com. I almost forgot my own damn website. um, you know, there's information on the website. I got to really get in there and I got to do some updates in there. But, if you need a tutor, I like the thing. I won't say I'm the best, but I'm one. I'm one of them. And you know, that's really all I have, guys. So I see 1, 2 people in the hangout. Okay. Don't worry if you see this late. You'll have up to like 15 minutes to jump in. But for right now, it seems like it's just Caroline and Avery right now. So thanks for watching, guys. I'll talk to you guys later. I will see you guys next week for all military aptitude test prep and all Federal Aviation Administration private pilot through airline transport pilot. I'm your guy. So I thank you guys for watching. Please hit the like button if you haven't already. And what else? That's really all I have. Do my little finger thing. Boom. All right, let's see.